Okay, here we are back again. So remember, I have this tetrahedron here, and there are no lone pairs on this. So the next thing we're going to look at, using our molecule kit, we're going to take out a blue ball, which is representative of nitrogen atoms, and we still need 3 hydrogens, so I've got 3 yellows. And then this time I will need 3 sticks. Now this nitrogen has 3 holes in it for the 3 sticks. So we'll put the 3 sticks in. Then we'll put the hydrogens on. And this is the structure we get this time. So you notice it's not flat. It doesn't sit in the palm of my hand. All the atoms don't fit on the palm of my hand, so it's not a planar molecule. It is a pyramid. Now, if this nitrogen had one other hole in it, we could see where that lone pair is. So that lone pair, remember, is responsible for the hydrogens being bent off at that 109.5 degree angle. Let me show you another way. So if we take our tetrahedron here and we take off one of the hydrogens and just leave that pair of electrons, we get the same shape. We get a pyramid shape. Now this pyramid shape is not symmetrical. In fact, remember the electron affinity trend? Nitrogen is on the side of the periodic table where the electron affinity is getting higher and higher and higher. So nitrogen is one of the most electron-hungry elements. In fact, the 3 most electron-hungry elements are nitrogen, oxygen, and fluorine. So because this is much hungrier for the electrons than the hydrogens are, and the hydrogens are not able to pull with the same strength because they're not evenly matched all the way around, there's not one up here, this becomes a polar molecule. We have uneven sharing. In fact, the little hydrogen atoms get the electron less. So that means their nucleus, their positive charge, is uncovered more. So this would be slightly positive, this would be slightly positive, and this would be slightly positive. And then the nitrogen, because it's getting more of those 3 electrons that the hydrogen is contributing, it's slightly negative. So it has more negativity to it. Another way to think of it is if you were going to play tug-of-war with Arnold Schwarzenegger and 3 Pee Wee Hermans. In this arrangement, Pee Wee Herman is always going to lose and Arnold the Terminator is going to win every time. So a polar molecule results when we have unequal sharing, and there are 2 factors that make it polar. It either has to be asymmetrical, usually they're asymmetrical, and you have to have a very electron-hungry element. So that's a polar molecule. All right, so this is our pyramid, 3-dimensional still, and it's like a tetrahedron with a lone pair on it.